Hi, I'm Spencer Pringle, Regional Sales Manager for Canada and the Pacific Northwest, and the next presentation is about how to make money with maintenance. In recent years, data has become an increasingly large part of the veneer and plywood industry. Rising production costs and competition in product pricing have forced mills to improve their production efficiencies by modernizing their production lines and upgrading them. The evolution of new technology has led to advanced collection, utilization, and integration of this data. The increasing possibilities created by data haven't, however, yet been fully realized by the maintenance departments in the veneer and plywood industry. Overlooking the importance of accurate process information and proactivity easily leads to reactive maintenance procedures that cause unnecessary downtime. Instead of treating maintenance as a necessary evil that only increases expenses, making your service agreement an intrinsic part of your data-driven operation opens new doors. The same analytics-based processes that you use to optimize your production can also be used to optimize your maintenance procedures. First, we'll cover how relying only on reactive maintenance is expensive and causes unnecessary downtime. We will then move on to the benefits of preventative maintenance, which is essential in increasing your equipment reliability. Finally, we'll introduce cooperative production optimization, which aims at improving KPIs by making maintenance an intrinsic part of your production process with a tight-knit service partnership. Unplanned reactive maintenance is considerably more expensive than planned preventative maintenance. However, mantras such as "don't fix it until it's not broken" led us to believe that reacting to breakdowns is a virtue, being proactive is considered lastly. The biggest problem with reactive maintenance is the resulting amount of downtime, which in the plywood and veneer industry can cost you up to thousands of euros per hour. While this approach saves resources by not stopping production for planned condition checks or regular maintenance, reacting to equipment breakdowns is significantly slower than planning for them beforehand. Another problem with unplanned maintenance is that when something breaks down, there's no plan in place to fix it. In the worst case scenario, you don't know what the problem is, what the root cause of that problem is, who has the expertise for that maintenance procedure, how much the maintenance costs, where are the spare parts for that, are they in-house or do you have to order them in, and what the delivery time of those parts are. In addition, you have no visibility into when the breakdown occurs, which means that your operation can come to a halt during the high season when you're at your highest production numbers. Even though unplanned reactive maintenance is up to twice as expensive as planned maintenance, some companies still use this for 90% of their maintenance efforts. Unplanned reactive maintenance is twice as expensive as planned maintenance. We'll never get to a point where sudden problems don't arise, but concentrating on preventative maintenance procedures enables you to better align your production strategy with your maintenance processes. Preventative maintenance aims at improving reliability and minimizing the effects of maintenance on production with systematical planning and preventative procedures. Making strategic decisions with the information provided by your maintenance and production processes enables you to create an accurate service plan that's based on the required volumes and quality targets. Next, we'll go through the key elements of preventative maintenance: work planning, execution, and management. For maintenance to support your strategic goals, you need to define KPIs that are aligned with your strategy, the tools to follow those KPIs and processes that support your strategic goals. When strategic elements have been defined, you need a schedule for daily, weekly, monthly, and annual maintenance tasks. The right maintenance intervals improve your system's reliability without doing too much maintenance. Defining a structured workflow for the required procedures ensures that the planned actions are performed, documented, and reported timely and efficiently. For example, annual maintenance shutdowns require accurate hourly plans for the execution of maintenance tasks, along with workshop and warehouse operations regarding the required spare parts and tools. Despite your best efforts, unexpected problems will always arise, and you need a plan for them. A remote connection with your service partner might solve a few problems quickly, and for more severe problems, you also need a clearly defined process for maintenance initiation and work order management. CMMS and analytics. The planning and management actions described above require a high-quality computerized maintenance management system, CMMS, that forms the foundation of your maintenance process and resource allocation. A CMMS is a database for all your maintenance operations, and it tells you the status of each maintenance assignment. It supports you in maintaining regular maintenance intervals, as all the schedules and plans are available through the system. Regulatory compliance is easier to achieve when you have a systematic process that considers both the business and regulation aspects. Getting accurate data about maintenance time between failures, failure modes, and equipment wear makes it easier to determine which parts require maintenance and when the optional time for service is. This is why CMMS is also an important part of ensuring that your maintenance KPIs and operations' most critical areas receive the attention they need. A CMMS is also an intrinsic part of the logistics and maintenance operations. When the time for a large maintenance project, such as a summer shutdown, approaches, you need to know the exact location of each spare part and tool. An up-to-date inventory and a clear-cut process to acquire new spare parts greatly improves the efficiency of your operation. International safety standards are steadily improving, and new regulations set requirements for investments and operating procedures. Job safety analysis can help secure that mill personnel safety every day. A well-structured service agreement improves the safety of both regular machine operation and the maintenance process. Preventative maintenance tasks. A proactive maintenance process should be concrete and take into account all the necessary procedures required for efficient and reliable mill operation. The process should especially concentrate on the areas that protect the equipment from breakdowns. These areas include cleaning, lubrication routes, condition monitoring, visual inspections, operators' preventative maintenance tasks. This 4-step preventative maintenance process shifts your resources from expensive reactive maintenance in a direction that allows you to combine your business goals, production process, and maintenance planning. These steps are also prerequisites for production optimization, since operations can't perform well without basic data capabilities, reliable equipment, and trained personnel. Next, we'll take a closer look at how cooperative maintenance optimization can improve the efficiency of your operation. The goal of optimization is to achieve maximum results for a certain production line as efficiently as possible. This requires refining and further developing your data collection and utilization. The result should be a systematic database of operation that analyzes and integrates all production and maintenance areas into a well-oiled unit. The data and analytics capabilities created for preventative maintenance, such as having a CMMS, pave the way for more advanced software and equipment required to fully optimize your operation. Optimization involves installing a manufacturing information system, MIS, that collects data on the production process from raw material to finished products and reports the information in real time to allow all users to see it. With this knowledge gained from the MIS, you can have concrete triggers that target events that you should react to. We already covered how a preventive service agreement requires commitment and cooperation with your service partner, but optimization takes the partnership to a whole new level. Optimization processes require daily monitoring and adjustments. Next, we'll cover some of the key elements of turning your service agreement into a cooperative optimization process. First, it's essential to emphasize that optimization is a joint process that only works when the service provider and the mill collaborate closely and both parties have a common understanding of the methods and goals. While reactive maintenance relies on sending an on-call technician on site and preventative maintenance focuses on regular inspections and planning. Optimization is based on continuous on-site presence supported by remote data analytics. Working together daily requires finding the sweet spot between the work cultures of two potentially different organizations and taking the necessary steps to refine the cooperation. An ideal partnership increases the know-how of both parties and improves your own capability to optimize your production. To know what to improve your production, you need to know how your equipment has performed this far. Your maintenance history data from previous years should be carefully analyzed. Getting comprehensive reports of operational failures and maintenance history gives you and your service partner a good overall view of the starting point of optimization. In order to get enough information for you to fully optimize your operation, you need to use your manufacturing information systems for further analysis on the reliability of your equipment. Root cause analysis is a method to analyze the system's failure and maintenance history. The idea is to define the failure modes and patterns that have led to a certain problem. When an accurate pattern has been identified, it's easier for you to find a solution that prevents repeating the inefficient patterns. Failure modes and effects analysis, Fmea, and condition monitoring concentrate on proactively preventing future failures. Fmea studies potential failure modes within the system already before the system is operational, which makes it a great tool for anticipating the effects of a proposed system update. Through condition monitoring, on the other hand, it can indicate significant changes in specific important parameters, such as temperature or vibration, which is vital in avoiding serious equipment damage. Performing these analyses systematically allows you to create a data-driven maintenance plan that continuously improves the reliability and efficiency of your production. Reliability is crucial for optimization, but it mainly guarantees that your equipment stays operational for a reasonable price. Another goal of optimization is to increase the mill's operation rate, which is achieved with good production performance. Adding overall equipment effectiveness, OEE analysis, to the mix provides essential data on availability, performance, and quality by assigning a score for each criterion. Taking into account both unplanned and planned stops, availability signals how much the potential production time you actually utilize. Performance takes into account the slow cycles and small stops and measures how well the system reaches its operation rate potential. Quality, on the other hand, detects how constant and defect-free the production is. Analyzing line recovery supports you in reducing the volume of raw material. If the amount of raw material consumed is high and the amount of finished product low, the system would benefit from optimization. Reliability and performance analysis are key for a successful operation, but it's also vital to align your company strategy with your maintenance and production goals. Having a clear, critically based hierarchy for maintenance and performance helps you in setting KPIs and triggers that support your strategy. This way, all the small details of your optimization process take you in the direction you are heading to in the bigger picture. After thorough reliability and performance analysis and strategy alignment, it's time to start the continuous improvement of the identified KPIs. What to consider when choosing a service partner. Ideally, your service agreement should provide you with high-quality services with the right scope for your needs. The partner should also be able to tailor and upscale their services according to changes in your operation. If you start with a frame of a service agreement and expand your operation, you need a partner there that is able to grow with you by taking more responsibility of preventative maintenance and supporting your maintenance management. The service partner should be ready to commit to a contract based on performance. Since optimization aims at production efficiency, the contract should include concrete metrics that affect the service provider's fee depending on the success. This way, the partnership is based on profiting together and also sharing the risk if the optimization doesn't work out. We believe that forming a close relationship with your customer allows both parties to learn from each other and achieve better results. When we know you, we can provide you with a service agreement that best suits your needs and current situation, ranging from a quick response frame agreement or preventative maintenance to on-site production optimization.